This is the first video where we're looking at how to draw valence electron core charge diagrams. What you want to do is take your blank copy and fill in, first of all, the group numbers, which I've listed here already. So 1, 2. Now normally boron, aluminum, etc. are found in group 13, but we're going to use a modified numbering system here. So I want you to list it now as 3A, 4A instead of 13, 14. 3A, 4A, 5A, 6A, 7A, and then up to the last group there and label that as 8A. You also want to take some time here, so probably pause the video and fill in all the chemical symbols for these guys. So hydrogen, lithium, sodium, potassium, beryllium, magnesium, calcium, boron, carbon, etc. all the way over to the other side. Aluminum, silicon, phosphorus all the way over to the other side. And then the row below aluminum, silicon, phosphorus, you kind of just ignore those. You don't have to worry about that at all. So we're just going to focus on group 1, group 2, and group 3A to 8A, but just more so the period 2, period 3 for the right side of the periodic table here. And again, note, there's this gap here because we remove the transition metals just because they kind of confuse us a little bit sometimes, and because they break rules that we tend to learn in high school chemistry. So once you've done that, you're going to have to grab this sheet here. Notice again this last row underneath aluminum, silicon, phosphorus, etc. has been removed. You don't have to worry about that. So we're going to use these diagrams, which we've already completed, to draw our valence electron core charge diagrams. Okay, so I've already got one done here. I've actually forgotten to fill in a couple of electrons here, so we'll do that now. So how did I get this completed? Well, if you look at aluminum here, all right, you'll notice that it has 1, 2, 3 valence electrons. The last shell here that has electrons in it is the valence shell. This ring right here is representing that valence shell. So you want to take the number of electrons to be represented here in the valence shell and color them in here. You also notice that we've got a large circle here with a charge of positive 3 in it, or 3 positive. How did I get that? Well, what you need to think about is everything inside of the valence shell towards the interior, the very center of the atom, is referred to as the core. So ignoring those 3 electrons, everything else is the core. And so what you have to do is add up the negative charges from the remaining electrons, add up the charges from the protons that are found in the nucleus. Okay? So when we count up the number of electrons in the core, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so I write down 10 negative. Now I get the protons. I've got 13p positive. So that's 13 positive charges. Add them together. So you're adding positive and negative integers together, and you're going to get an overall answer of positive 3. All right. Let's do the same thing for silicon. Look at the number of electrons that silicon has in its valence shell. 1, 2, 3, right here, 4. So you want to go top, bottom, which is a pattern we learned before, left, right, and there's your 4 valence electrons for silicon. Let's figure out the core. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So 10 negative. How many protons do we have? We have 14 protons. So 14 positive. Add those together, and you're going to get an overall charge of 4 positive. Okay? So that's kind of how you do it. There'll be a second video now, and I'll randomly choose some guys at different positions along here and do those as well. Okay?